I wanted to start off this presentation by telling a joke about algae. I realized I didn't really know any. Got 2 engineers and 2 algae swimming around in a photobioreactor. Doesn't really go anywhere, sorry. So we'll just talk about algae. This is a gas processing facility. This is one that was built by my team in 2005. This is what's known in the oil and gas business as a gas plant or a compressor station. So what you have here is you have low pressure gas coming in and you have high pressure gas going out. And this is gas processing equipment here to take carbon dioxide and water out of the gas. At facilities like this, the carbon dioxide is just vented into the atmosphere and the gas is shipped all over North America. Your gas is coming in at the wellhead at very low pressures for production purposes, and it's going out at enough pressure so you can move it all across North America. So this should be no stranger to anyone who lives in Alberta. You get a vast amount of heat and you get a vast amount of exhaust. You have these engines running, and these engines are burning natural gas. And in the process of burning natural gas, of course, creates a large amount of heat and a large amount of exhaust. Over 2% of Canada's greenhouse gas. This is just from the compressors in Alberta. So it's a very, very significant amount of heat and CO2. This is a map of central Alberta. Calgary's here, Edmonton's off the top. This just shows the larger facilities. It's not even showing the smaller facilities that are straight compression. There's 5,600 plus compression facilities in Alberta. So there's an enormous amount of these facilities. We use the term rejected heat, not waste heat. You'll hear waste heat in the industry, but we don't use waste heat because waste implies sort of a disregard. And in fact, the heat that comes out of these facilities is a basic byproduct of the thermodynamic process of burning fuel. So it's not really waste heat. What happens is that the compressors in Alberta burn about 7% of the gas that's produced. All right, and in the industry, that's called shrink. It's accepted as a basic cost of doing business. What you'll do as an oil and gas operator is you'll optimize your compressors and then you'll say, okay, this is as good as it gets, the rest of it's thermodynamics. And so you're burning 6 to 7% of the gas that you produce in your compressors, and it's a business cost. So what you have is gas exported to Canada, gas exported to the US, gas used in Alberta, and then this red slice, which is the 7%, is the gas that's burned in compressors. Now if you take the shrink and you go down here, what you have is somewhere around 38% of the energy in the gas that's burned creates mechanical energy. It turns the compressors. The rest of it is lost as heat. If you buy $1 worth of gas for your car or your SUV or your hybrid if you're a responsible environmentalist, you go down the road, 30 cents of that heats the exhaust that's coming out of your exhaust pipe, 30 cents of it heats your radiator, and the other 40 cents moves you down the road. Now if you ratio your weight with the weight of your car, 1 or 2 cents of that is moving you down the road. And actually it's way worse than that, because those numbers assume that your engine is operating under full load at full efficiency. If you cast that transportation analogy, it really doesn't make sense when you sort of look at it that way. But this is what's happening in the compression world. If you take the heat that's actually rejected from these compressors and you look at how much it takes to heat a house in Alberta, we have 1.2 million houses in Alberta, and we could heat 1.4 million with the heat that we're rejecting from our compressors. So we're dumping enough heat right now so we could get rid of all the furnaces in Alberta if we could use that heat. In our algae farm, we have 4 inputs that are necessary for growing algae. We've got heat, light, exhaust, and nutrient. The exhaust is CO2. And so we grow this inside our farm. We get biodiesel feedstock, we get high protein biomass, and we get greenhouse gas credits for getting rid of the CO2 out of the exhaust from the compressors. Everyone's seen this before, I'm sure, in this room. Anyone who's interested in biofuels has seen this, because algae is a pretty popular area of bioenergy now. The difference between SFN Biosystems and everybody else is that of these 4 inputs, we get 2 of them for free, which are the heat and the exhaust. And then the third one, which is light, we can also make essentially for free from the heat. So the only input that we have to buy is the nutrient, which changes the economics of the process quite dramatically. This is a process summary of how this works. By the standards of oil and gas, operating people, this process is extremely simple. There is nothing complex in here. It's a very, very simple process, although this is kind of a horrifying diagram. What you're looking at here is you have an engine, a large engine that's running under full load, burning natural gas. rejecting heat to the environment through a radiator and also through the exhaust. We recover the heat from the radiator and the exhaust, and we use it inside our photobioreactor to maintain our system at the right temperature, which is a relatively simple process. This box represents the photobioreactor, and what we have in here is we have a bunch of light, we have it at the right temperature, and we have a nutrient-rich growing media, and we have algae that grow at extremely high rates inside the photobioreactor. We can recirculate the exhaust to make sure that we get the right amount of CO2 uptake. We continuously harvest the algae out of the photobioreactor to maintain the algae concentration at the optimal density. And algae will grow extremely quickly under the right conditions. You can get cell division 4 to 6 times a day. Really a problem of trying to turn your hot tub green on some level, which if you've ever had a hot tub, you know it's not that hard. We've been able to grow algae at extremely high concentrations. We made some business decisions when we started this company in 2005 that turned out to be fairly correct in terms of how things played out. One of them is that natural light is not sufficient for input for growing algae. You have to use artificial light. And there's a number of other decisions that we made that turned out to be fairly accurate. So this is what we're doing. It's very simple. It's a large algal biomass production facility. Basically what this is it's a bioenergy and greenhouse gas reduction project. We're using rejected heat and CO2 emissions from natural gas compression facilities to grow algae. We can produce bioenergy from the algae. We can reduce greenhouse gas emissions, and in our test facility we've run for sustained periods where we've knocked 90% of the greenhouse gas out of the exhaust. So we've had extremely good results over sustained periods on greenhouse gas reduction. So really we have the 3 elements in our economics. And our economics are pretty favorable. We have partnered with Encana Corporation. They've made an investment in our company, and that's based on the economics that we have, not on the environmental impact and so on. It's a straight business investment. Our project is basically a bolt-up. We don't like to do new technology projects as a small group, with limited capital. You have to be very careful what you get into, and most of the components of this project existed before we started, with the exception of the biological technology. The rest of it is what we refer to as a bolt-up. We actually started in 2002, and then we really kicked this project into gear in about 2005. We've shown excellent results. We have some very, very strong IP on our photobioreactor technology. We got into this technology really before anybody else was doing this. In 2005, the algae world was pretty skinny, so we've been able to secure some very strong IP. We've partnered with Encana, and we have some private equity backing as well. So we are currently building a cell of our commercial system, and we'll start rolling the commercial systems out at the end of this year. So that's where we are. Essentially what it is it's a box of light kept at the right temperature, and the algae is kept at the optimal concentration inside this box, grows at very high rates. We have a single cell, and our system consists of ganged cells, so there's no scaling issues. We'll just add as many cells as we need to process the exhaust that is required. Now, this cell is the size of 2 40-foot containers stacked on top of each other. This 8-cell unit here is what we anticipate needing to process the exhaust from a Caterpillar 3516, which is an 1100 horsepower engine used to drive compressors. It's a very common engine used in Alberta. The footprint of this unit is about the same size as the footprint of the compressor itself. We pioneered some advanced noise attenuation technologies, and we've done some other things in the past in the oil and gas business, so we have some experience with this. There's a process of identifying the things that you don't know when you're doing a startup and working on those first, and that is really well defined in this book by Curtis Faith, Inside the Mind of the Turtles. I hate it when people refer to business books, but this is a particularly good one. So anyway, that's been really helpful to our team. We only do bolt-up projects, so we look at things and we say, how many unknowns are there in this, or how many things are there in this project that we haven't done before that we don't know that we can do? If there's more than 2, we won't do the project. If you want to implement anything on a gas plant site in Alberta, there are approximately 17,000 pages of regulations in Alberta that relate to construction inside gas plant facilities. My team is intimately familiar with all of those regulations. We talk a fair bit about our project and what we're trying to do. If other biofuel producers want to implement a project inside a gas plant, our suggestion is go ahead and try. You know, if you haven't done this before, it's super difficult to do. And so it's very important to identify you know, what the actual issues are and make sure that you've done this work before you launch into a startup, because otherwise, you know, you're going to be another statistic. We use the most advanced tools, so we have the financial resources and the wherewithal to use the knowledge and skill to use the best tools out there. So we use, you know, state-of-the-art you know, tools and technology in our development. And this, you know, this applies to software, but it applies to a number of different areas. And we believe that you know, business is about execution. It's not about strategy. This is a quote from when I was a vice president at Schlumberger. The chairman of the board told me this once when I was making a presentation about strategy, which was sort of the end of my presentation, when he indicated that he wasn't interested in strategy because business is about execution, not about strategy. This is very, very critical. We focus on the execution. People are critical. You've got to define your required skills. You've got to be realistic about what you can get in the market, and you know, that's not easy either. Seek advice from people that you know, that are experts in your area, and try to build that network. You've got to understand the risk and return and the kind of you know, people that are interested in working on the kind of things that you want. A lot of the individuals in Calgary who have the expertise that we need in key areas of what we're doing would never ever work for a startup like ours. So it's just not realistic to try to recruit people that are in that, you know, in that situation. So you have to be, you know, realistic about that. We partner with groups that are doing parts or components of our project. You know, if somebody's already doing something that we're doing, there is no way that we're going to start doing it ourselves. We'll figure out a way to work with someone who's got that area of expertise. You know, as an example, in the greenhouse gas credit trading sector, there's some folks in town who have been doing that for a long time, who are state-of-the-art leaders in that area, and we formed a partnership with them, and they'll deal with that for us. We're not going to try to build that expertise or knowledge in-house. In a number of ways, Calgary is not a good place to do startups. This town is controlled by the oil and gas business, and you know, people who have worked in the oil and gas business have some fairly, you know, strong expectations about how they're going to be compensated and what they're going to be doing and so on. And for a startup, if you're not in a position to meet those expectations, you're in tough. The other problem with Calgary from that regard, most of the manufacturing, I would say, relates to the oil and gas business. And again, they operate on a different financial level than, you know, folks like us do. So it makes it very difficult to operate here. So that's another thing you've got to be realistic about. You know, look for the opportunities that are in front of you. This project came out of the fact in 2002 we started looking at shrink. We started looking at the reduction in the gas that we were burning to run our compressors. We started doing an efficiency analysis you know, on facilities. In a week or two, we came up with an idea that allowed us to reduce the capital cost of our facilities by 35% and improve our operating efficiency. And that was building a facility that was very, very similar to the 5,600 facilities that already exist in the province. That's really what got us encouraged on this project. Was we thought, well, if it's this easy at this point, there's got to be other things out there, and that's what led to SFN Biosystems. So the comment is, look for the obvious that's in front of you, because sometimes you know, it's right there. I think scale is important too. You've got to think small, not big. One of the questions that I was sitting at the back of the room kind of laughing during the last question period, no offense to anybody, but you know, we're here at a Calgary Advanced Technology Forum, and you know, the previous speaker received, I think, about 8 or 9 super negative questions, you know, about you know, the technology and what he was doing and so on. And I always find that kind of entertaining, because you have to really, I think, do startups, you know, for a while before you start seeing the humor in that. What happens is that if you think about the big picture, you can't get anywhere, because obviously, you know, if you could make gasoline from triticale, then we'd be burning gasoline from triticale, okay? And it's fairly obvious that the inputs, you know, are more expensive than the outputs, and you know, we can all do that math, right? Inside that industry, where are the smaller opportunities, okay? Inside that industry, where is the one piece of that you can do as a startup? Maybe control some IP and position yourself to, you know, make a bunch of money, you know, going forward, or be successful going forward, okay? You don't need to own the entire triticale industry, okay? And if you try to do that, you're not going to have a good result, okay? Especially if you're 3 people working out of a converted warehouse, which is how we started, right? So you need to look for small pieces of it that you can move forward. And if you're financing these things, there's some investment bankers here. You need to look for the people that have a small piece of the technology that they can move forward, right? It's about small steps, right? Again, look for limited complexity. If you don't understand half the technology, or if you're trying to start a company and you've never run a company, forget it. If you're trying to start a company and you've never run a company, go find someone who knows how to run a company. The learning process on that is going to kill your technology project. There are lots of people in this town who know how to run companies, right? Assemble the right people, that's not easy. It's a big challenge, and use the best tools you can get.
In some country like Germany or US, now you're using special procedure to reduce the CO2 from the natural gas. I heard, if I remember correctly, the average cost for 1 ton CO2 reduction will cost about $100. And they are inventing a new procedure using ionic liquids. They assume that the cost will be about $30 or $40 per ton CO2. And I want to know how much cost you are taking to reduce 1 ton CO2. And also I want to know, nowadays the procedure for reducing CO2 is using the amount-based procedure. I understand that your technology is kind of intellectual property, so I wouldn't mind if you don't answer this question.
There is no issue around intellectual property with this. Our economics are run at $15 a ton for CO2 reduction, and our economics are robust at $15 a ton. So we make money at $15 a ton. Now, the whole issue of CO2 reduction is an interesting one, okay? And we get asked a lot about this. We get asked about greenhouse gas, about global warming, and about a whole bunch of things that I don't understand. The only thing that I know is that less pollution is better than more pollution. And what happens is people like me who have installed, I've been responsible for installing hundreds of thousands of horsepower of natural gas compression over the years. People like me have an enormous impact on the environment, all right? More so than the people in Greenpeace and everybody else, because we're the ones who build the stuff that spits the emissions out. What happens is that we have a system here that can effectively reduce the emissions very significantly, and we can make money while we're doing it. With regards to the other technologies that are out there, we don't see any competition between these technologies. So carbon capture and sequestration, for example, the Alberta government is spending a lot of money on research on carbon capture. We totally support that. Let's get that's a technology that applies obviously to larger sites, whereas our technology applies to smaller sites. Any carbon reduction technology that involves scrubbing exhaust, which is what you're talking about, with the amine process and so on, is going to be difficult to make work in the short term. The economics are going to be tough. Various technologies that are being developed now for CO2 reduction or CO2 elimination from exhaust streams, my personal view is great. I think it's great. There's room for all of them out there. And we got a call from a very large petrochemical company recently who's interested in our technology, and they're looking at one project in Asia, one petrochemical facility in Asia, and that petrochemical facility spits out 1,000 times more CO2 than our entire business plan involves with Encana. So there's lots of room in the world for CO2 reduction technology.
Do you guys intend to make the biodiesel from the oil yourselves, or do you intend to sell it forward to another producer?
The short answer is no, we're not going to make biodiesel. We don't think biodiesel processing is a viable business. If you went into Alberta in 1940 or whatever it was, right, people were cooking gasoline for their car in their garage. You're not going to buy a $55,000 diesel 3/4 ton and buy fuel from someone who's cooking it in his garage. So what happens is that if you look at the history of the energy industry, and you don't have to be very smart to do this, okay, there's always been a large consolidation of refining, okay? So, one of the hedge funds that I work for made a big investment in Brazil in biodiesel refining, and all the medium-sized biodiesel refiners in Brazil are now broke. We think what's going to happen in the end in Alberta is there's going to be one big refinery run by a big oil company that knows how to market the product, okay, that does all the biodiesel processing, and everybody else is going to be broke. So consequently, we're not really interested in the business. So if that's offensive to anyone here, I apologize, but that's how we see My brother's a professor of mechanical engineering at the U of A. He's got a PhD from Stanford, and he works on combustion and engine control systems. And if you want to talk about fuel and fuel stability, I'll give you his number. Go talk to him. It's quite an interesting process. And when you look at the big refineries in Alberta that make transport fuel now, go for a tour, see what they do, you start getting some appreciation for how complex that industry is, right?
Alstom had suggested that in their technology assessment, they were looking at algae being a solution maybe 15 to 20 years down the road. Now, it's not clear to me from their presentation whether they were talking for large-scale systems like they're talking about at Keephills 3. Do you have any perspective on that, John?
Essentially, it's an overall process energy balance, really. Anytime you add process elements, you add additional elements into a process that require energy inputs and so on, then you increase the the complexity of that process and you change the economics, right? Our technology, as we've developed it, has a very, very specific application. The exhaust from natural gas, it's not going to work in the exhaust from a coal facility, okay, because or it may at some point in the future, but now it won't because the algae that we grow won't survive in that exhaust stream. Our process is freshwater positive. We actually create water in our process because we capture the combustion water from the exhaust, okay? So we're actually freshwater positive, right? Which is just bizarre. We have an issue around disposing of fresh water. On the smaller compression facilities that we're operating on, which compared to a large power generation plant or so on, these are relatively small facilities, although they all qualify as large emitters under the EPA standards. You don't have the capability to run a complex process on the exhaust. So our process is extremely simple. What happens is the exhaust comes out of the engine. The exhaust is run directly through our photobioreactors. The CO2 is taken out, and the cleaned exhaust is basically vented to the atmosphere, right? So for our specific application where we specifically are, the technology makes sense. I think that a lot of the other carbon technology, again, if there was money in disposing of carbon, of CO2, we'd be doing it already, okay? So, I think a lot of those other technologies are a long ways down the road. And as someone who, has spent my whole working life trying to get gas out of the ground, I have a very, significant appreciation of what it takes to put it back into the ground. I would be naturally skeptical about, a number of the technologies that are out there in terms of their realistic cost. But again, there's room for all these technologies in the right application, right?
What do you do with the algae?
So what we do is we produce biomass, okay, and the algae contains about 20% oil. The remainder of the biomass is roughly around 50% protein. So there's a wide range of products that we can make. The algae business has been driven by energy, okay, because what's happened is that all the funding has come from energy sources, okay? So if you look at the energy world, it's Exxon Mobil, doing genetic engineering on algae. It's a bunch of energy, and most of the funding sources in the past have been research funding sources have been energy related. But the oil extraction is only a small part of it, okay? And that technology is moving forward pretty rapidly. So what we're doing is we're partnering up with some algae extraction, with some harvesting people, basically, if you like, right? And we're going to extract biodiesel feedstock and sell it to biodiesel processors, and they're short of feedstock, okay? So that's where we want to be in the supply chain, right? And then we're going to extract some other compounds from the algae as well, which we're not talking about at this point. And then we're going to, sell the remainder essentially as animal feed into an established market. And we've got, partnership arrangements lined up for that, and our economics are robust.
What are some of the challenges getting financing or pulling a project together to attract financing from the overall finance community, whether it's the hedge funds, as you had mentioned, or partners like Encana?
I can answer that a little differently than I would have about 5 years ago when I was assuming that there was going to be no problem financing this project, and I was completely wrong. There's a couple of things there, right? We got some help from IRAP, and IRAP turned out to be an outstanding partner for us because we got way more help from them than just financing, okay? So, I think that I would categorize IRAP, in the case of our company, as really a partner rather than, a funding organization. And so, I think we were extremely fortunate there in terms of the relationship that we got with IRAP and the people that we dealt with there, and the support that they provided us over, a period of time. We wouldn't be here without IRAP, basically. Okay, so that was a key part. I think that beyond that, it becomes pretty difficult, all right? And the last few years, the situation over the last couple of years hasn't helped. The venture capital industry in the United States has completely fallen apart. One comment I would make is that if you're trying to finance a project like this one, don't try and do it in Canada. That would be my comment. You're far better off to go south of the border. They have a completely different attitude towards financing than we do here. And the way that we describe that, and again, sorry if I'm going to offend anyone here, but the way that we describe that is that, if you look at, myself, for example, I've been responsible for all the operations for 3 startups that started organically and, were valued at well over $1 billion when they were sold. When you go looking for financing in Canada, the financing, the private financiers, the venture capital people and so on, will look at your project and go, well, like, why do you have this pump here and shouldn't you have this pump here? And, this is my 25-year-old engineer who's never built anything, but he's going to tell you that the energy balance doesn't work out. And then, we've had oil company executives lecturing our PhD biologist on photosynthesis reactions and the stoichiometry, and this, so on, okay? So that's how it works in Canada. We find that when you go south of the border, what happens is people will look at you and say, okay, what have you done and why would I think that you can do what you're going to say you're going to do now? Okay, so it's a very different mentality, and I think that you're far better off to try in that market, really. So that's, that would be my view or our view. And so what we did in this project is that in the early days we financed it ourselves, okay? We had some help from IRAP and a certain amount of help from the Alberta government, right? And then when we realized that we had something here that was going to work, we went to finance the company and we tried a number of things. It took much longer than what we expected. It actually set our plans back by about 1.5 years, and it was a very, very painful 1.5 years. I contacted 290 different funding organizations in the process of that 1.5 years. And these are, a number of these are groups or people that I have strong relationships with, okay? We've done a bunch of work with Piper Jaffray, for example, who has, done most of the bioenergy IPOs in the US, okay? So I know those people. So anyway, we had some pretty good contacts, but it was very, very difficult to put the money together. But in the end, we made a deal with Encana that's a good deal for them and a really good deal for us. And any further funding we do, we're going south of the border. So what we'll do is we'll line our investment bankers up. We'll set up 4 meetings in one day with 4 Canadian funds in order to fine-tune our presentation. Okay, that will be the objective. And then we'll head south of the border where we think we'll actually get the money.
Have you had any difficulty positioning yourselves as a biorefinery versus a biofuel company? Have you had much difficulty in communicating what a biorefinery actually is? Or the concept of it versus a biofuel play?
I don't want to start, dissembling here because I know everyone's tight for time, but, it's very, very hard to sell anything to an oil company, right? And our technology really applies to, natural gas producers, all right? So what we did is we stuck to our balance sheet. We have, an economic model that is very robust, all right? And so what we were looking for is we were looking for someone who's mostly interested in the economics, right? As opposed to the detail of the, of the technology. We had we went through 8 months of due diligence with Encana, so they scrubbed our technology down in some detail as well, obviously. But, we were trying to position ourselves that way, and that worked for us.
There are a couple of things that the investment community values very highly in assessing opportunities. One is a good management team, so that's universal, and with a proven track record. And the second one is in fact the economics, because investors, when they look at an opportunity, it's all about assessing how can they make money off of it. And so if the economics, if there's not a strong business case around it, that's where many opportunities really fall off the table. And as part of that, in a startup, what you're looking for is a pretty clean, simple revenue model. You get a lot of moving parts, on a startup, and it becomes very difficult to manage all those different product streams, and the economics tend not to hold together that well. I'm taking from your presentation that Your real value proposition is the carbon capture piece, and that's where you're generating your revenue. And so I don't believe there's currently an open market for carbon credits or carbon capture in that extent. So I assume this is a private arrangement between your company and Encana.
First of all, we do have an arrangement with Encana on CO2. Okay. Secondly, we have a revenue stream that's generated from biomass, from protein, and also from the oil content of our algae. So we have three revenue streams. I would also say that I really have to completely disagree with your comment about what people look for in a startup and how that goes. Okay, I've spent a number of years looking at all the energy investments for a couple of $80 billion hedge funds through my firm, and I've advised Goldman Sachs and others on their energy investments. Okay, so I have some familiarity with the economic part of it as well. Okay, and I would say that I would look at that totally differently, rather than looking at the complexity of a complex revenue stream and so on, and this and that, which is exactly what I alluded to earlier as the Canadian approach to this. Okay. I think the way to look at the economics of a startup is on a risk-return basis. Okay, so if someone is trying to build a better widget that they can sell for 5 cents less to someone, and those widgets are already being used by everybody or whatever, you define the upside in the project, and then you look at the investment required from a venture capital standpoint, and you look at a risk-return. You look at it from a risk-return basis. Okay, that's the analysis that really needs to take place in when investing in startups, as opposed to you can break down. Dilbert once said, in my all-time favorite Dilbert cartoon, right, that as the pointy-haired guy came in and said, "Dilbert, how long is it going to take you to debug this software you're working on?" Right, and Dilbert looked at him and said, "It's a logical impossibility to schedule the unknown." Then his boss said, "Listen, stop thinking like an engineer and start thinking like a manager." And so what happens is that if you ask a firm like ours to schedule the unknown, that's a logical impossibility. It's a statistical impossibility to predict the future price of oil. Okay, and the folks here from the Haskane can tell you that. All right, so you have to look at it from a risk basis. I don't agree with that form of analysis at all. We can take our business plan and give it to you, and you can strip it down and say, yeah, okay, and we've of course run sensitivities on everything. Like I said, I used to work for Goldman Sachs. I know how to do this, right? But we've run sensitivities on everything and all that. But what you got to do is you got to risk those sensitivities. And if you're not willing to risk them, then you're never going to get there on financing, something like this. And then people like me shouldn't be talking to you, because it's never going to happen. And we have, the problem we have is that myself and my partner spent, a year and a half doing this when we could have actually been building. And it would have saved us a lot of time had, a number of those organizations indicated up front that, they didn't do this kind of stuff, right? Which in reality they don't, even though they actually say they do. Sorry again to anyone who's offended. We actually have nice people who work in our company.